Welcome back. This is activity 3.3 in a formal affair. Let's get started. As you have seen, there are multiple ways to solve equations. Sometimes an efficient strategy involves changing the numbers in the equation in mathematically appropriate ways, of course. Question number 1 reads, analyze each correct solution strategy to the equation 1 and 1/10 x plus 4 and 3/10 is equal to 6 and 2/10. A, you're going to explain how the two solution strategies are alike and how are they different. And B, what property of equality did Maya apply before she started solving the equation? Remember, the property of equalities are the addition property of equality where you're adding to both sides, or the subtraction property of equality where you're subtracting to both sides. Set a timer for 2 to 3 minutes to answer questions 1A and 1B, either on your own or with a partner. Pause here. Alrighty, let's go ahead and compare answers. For 1A, they both got the same answer, is how they are alike and how they are different. Maya solved using whole numbers and Sherry solved using decimals. If you noticed other things that were different and alike, that is okay. For B, it says, what property of equality did Maya use? Well, Maya used the property of multiplication. She multiplied both sides by 10. And when I say both sides, I mean both sides of the equal sign. So she had to multiply 1 and 1/10 times 10. That gave her 11. 4.3 times 10, that gave her 43. And 6 and 2/10 times 10, that gave her 62. Remember, when multiplying by 10, that moves the place value. So that is why in green, I showed the decimal moving. But if you don't believe me, you can multiply off to the side for yourself to see that you will get these answers. If you need to, take a couple seconds to get these notes. About 30 seconds. Pause here. Moving on to question number 2. It says Brian used Maya's strategy to solve the equation 2 and 6/10 x minus 1 and 4/10 is equal to 38. Identify his mistake and then determine the correct solution. So you're doing two things here. Looking at his work, comparing it to Maya's to see what he did wrong, and then solving. Go ahead and solve this either on your own or with a partner. Set a timer for about 3 minutes. Pause here. Alrighty, let's compare answers. So we first identified his mistake and then determined the correct solution. So Brian's mistake was that he did not multiply both sides of the equal sign by 10. Yes, he multiplied 2 and 6/10 to get 26. Yes, he multiplied 1 and 4/10 to get 14, but that 38 stayed the same. We have to do the same thing to both sides to keep it equal. So when I did, I got 38 times 10 is equal to 380. And then I was able to solve this two-step equation. Notice in orange, and hint, hint to those of us that didn't do so well on that exit ticket, pay attention. The first thing I did was I added 14 to both sides to get rid of that 14 because I want to isolate that variable. I want to get it by itself. Then I was left with 26x is equal to 366. Then, to get that x by itself again, I know I need to do the opposite of multiplication, which is division. So I would divide both sides by 26. And notice in black, I showed my work. 366 divided by 26 gave us 14 wholes, 2 left over, and then our denominator stays the same, 26. So 14 and 2 over 26, which then simplifies if I divide the top and bottom by 2 to 14 and 1/13. If you got to 14 and 2/26, that is also okay. They are equal. Just remember next time, see if you can simplify. Go ahead and take a second to get these notes. If you don't have them, about 30 seconds. Pause here. Now let's move on to question 3. It says use my strategy to solve each equation. Then check your solution in the original equation. So on your own or with a partner, you're working on these two problems. If you are in my class specifically, I want you to focus on 3A for time purposes. My class, set your timer for 5 minutes. Anyone else watching this video, set your timer for about 5 to 10 minutes. Pause here. Now that you've had time to work, here's the solution for A. Step by step, I multiplied both sides of the equal sign by 10. Then I subtracted 18 from both sides. Then I divided both sides by negative 96 to get my answer of 1 and 45 over 96. I know these numbers aren't pretty, but don't focus on the numbers. Focus on the steps and focus on the process. And for 3B, here is my process. Now notice with B, I multiplied by 100 and not 10 because 2 and 99 hundredths and 13 and 55 hundredths end in the hundreds place. So I wanted to get rid of those decimals. So I multiplied by 100 to move my decimal twice. And so then what I did to those two numbers, I also had to do to that 1 and 4 tenths. So I moved it twice. It made 14 and then 140. Your final answer was x is equal to 5. Take a second to pause here if you need that work. My class, keep going. Moving on, now let's consider strategies to solve two different equations that contain fractions. Question number 4 reads, answer each question about the strategies used to solve each equation in the worked example. For A, explain step 1. Why might this strategy improve your efficiency with solving equations? Also, I didn't explain this before, but efficiency means just to be able to solve your equation quicker, easier, faster. 4B says what property was applied in step 2? And 4C says explain step 3. At this time, go ahead and analyze the worked example to answer questions for A, B, and C. Remember to annotate so that you can truly understand what's happening and highlight the thinking. With a partner or on your own, set a timer for about 3 minutes to complete this. Pause here. Alrighty, let's compare answers. And as always, your answers may vary. So if they're different from mine, that is okay. So for A, step 1 helps us solve by creating whole numbers. So notice what they did in step 1 with purple or in purple. B, the property that was applied was the multiplication property of equality, because when they multiplied 3 times each of those terms in the equation, then they got 11x plus 15 is equal to 17. And then on the right side, the same thing. They got 2x because 4 halves is equal to 2 wholes. And then 3/4 times 4 gives you 3 wholes. And then also 4 times 2 gives you 8. Another thing I want you to notice in the second problem, they could have multiplied both sides by 2 to make 2 halves into 1 whole. However, they noticed that they also had that 3/4. And if we simply multiply that by just 2, it would have stayed as a fraction. So we use the bigger denominator, or here in this case, we used the bigger denominator to multiply to get that whole number. And then for C, in step 3, they subtracted and divided both sides at the same time to isolate the x. Alrighty, moving on to the next question. Question number 5 reads, Luis used the strategy from the worked example to solve 3 is equal to 1/4 x minus 1/4. Identify her mistake and then determine the correct solution. Number 6, use the strategy from the worked example to solve 2/3 x plus 4/5 is equal to 5/3. Check your solution in the original equation. So at this time, you're working on your own or with a partner. Set a timer for about 10 minutes to answer 5 and 6. My class, I want you to focus for time purposes only on number 5, identifying Luis's mistake, and then determining the correct answer. Be sure to show all of your work. Pause here. All right, now that you've had time to work, let's compare answers. Luisa's mistake was that she did not multiply both sides of the equal sign by the same number. Therefore, she did not keep it equal. So when you multiply 4 times those fractions, you also have to multiply 4 times that 3. So then I set it up to solve correctly. 4 times 3 gives us 12 is equal to x minus 1, and then x is equal to 13. And for 6, here is my work. Sorry if it's a little messy, I ran out of room. But looking off to the right in blue, I multiplied both sides of the equation by 3. That gave me 2x plus 12/5. Now that 4/5 doesn't turn into a whole number, and that's going to happen sometimes. You could also turn that into a decimal number if you'd like to solve that way as well. Remember, 4/5 is a benchmark fraction, 0.80 or 0 and 8 tenths. And then that 5/3 times 3 turns into 5 wholes. Then I subtracted 12/5 from both sides. Then I divided both sides by 2. And my answer was 1 and 3 tenths. If you need a second to get this down, pause here. If you're in my class, keep moving forward. And we're on the last page of this activity. It says, consider the solution strategies used to solve 2 more equations. Answer each question about the strategies used to solve each equation in the worked example. 7a, how was the strategy used in this pair of examples different from the strategies used in questions 1 and 2? 7b, when might you want to use this strategy? And C, use the strategy from your worked example to solve 44x minus 24 is equal to 216, and then check your solution. Set a timer for about 5 to 7 minutes to work on your own or with a partner to answer questions 7A through C for your final practice in this activity. Pause here. Alrighty, now that you've had time to work, let's go over this final question. So 7A, you could have wrote something similar to, instead of multiplying, they divided each term in the equation to reduce it to a smaller number. For B, you might want to use this strategy when the numbers are larger. And for C, using that strategy, we solved 44x minus 24 is equal to 216. And you can see my work in blue. Also, off to the left, I want you to see how I've identified that I was going to divide each term by 4. I found the greatest common factor between each of those numbers, 24, 44, and 216. Yes, I didn't write them all out, but that's the gist. And then I could pull out 4 from each of those. Then I got 11x minus 6 is equal to 54. Then from there, I solved my regular 2-step equation. I added 6 to both sides, and then I divided 11 on both sides. And in black, you can also see my work for the division. Alrighty, and that concludes the practice for this activity. Pat yourself on the back because that was a lot of work. I hope you took great notes and I hope you learned something, and I will see you in the next video.